This is the talk on JUnit 5. I'm going to assume that you are reasonably comfortable with JUnit in general, especially JUnit 4. If you have some experience with JUnit 5, so much the better. If not, don't worry about it. But I hope that I will cover at least a handful of things that you may not have seen or may not have seen recently. There have been a lot of improvements to JUnit over the past few years, and I mostly want to illustrate that. Now, my name is Ken Kousen. It's Kousen like the relative. It just doesn't look like it. It got changed at Ellis Island or something like that. Nobody really knows. So at any rate, there's all my contact information. That QR code, by the way, goes to my YouTube channel, the link at the bottom, which is called Tales from the Jar Side. It's a pun, you know. I also put out a free weekly newsletter of the same name, which is hosted on Substack. Those are all the books that I've written in the past. Regarding JUnit, I have used JUnit testing for all the languages I've coded in, Java and Groovy and Kotlin. Kotlin especially, it was not clear which was going to be the definitive testing library in Kotlin. There were a lot of choices. So I figured, how the heck with it, I'll go with JUnit, and it worked like a charm. Did a really good job. So I've been working with that a long time. At any rate, there's my email address, homepage, Twitter handle, which I try to avoid, but it's still there. I do spend time on Mastodon and Blue Sky and Threads, all the others. Feel free to contact me whenever you like. Okay, now, JUnit is located at junit.org. I actually have over here that site opened. It redirected to /JUnit5. There's a link to the older one. What's on here is a very good user guide, the very solid user manual. Also the Java docs, which in principle you would need. There's some things I want to talk about in there, but I'll just tell you about them. But if we need to see it, it is in here. The code and issues takes you to GitHub. And that's fine as far as it goes. I do want to show you one thing on that. So if I go to the code and issues here, you'll see that this is the JUnit 5 repository, inside the JUnit team organization. And if you go up to the organization, you'll see that there is a repository called JUnit 5-samples. If you're ever not sure how to add JUnit to a Gradle project, Maven project, SBT, Ant, I mean, what have you, that's what's in here. They have examples of how to add it to, well, Basel as well, Gradle, Maven, SBT, on, and those projects will just show you the build file and give you the, quote, definitive way to add JUnit. Not that it's all that difficult, but I thought you might like to know about that. Now, if I go back to JUnit 5 here, there's a Q&A here which takes you to Stack Overflow. And remember when we used to go to Stack Overflow before you had GPT or something like that? Yeah. So anyway, that takes you to a Stack Overflow where there's a tag for JUnit 5 in it. But I want to mention in here that this is basically a collection of all those links that I just went through. Nothing unusual about that. But this one here that says Gitter, the JUnit 5 team maintains what they call a Gitter group. Gitter's like a Slack page. You know, it's not in Slack, it's in a web page. And they've got group and topics and questions, and a lot of the JUnit organizers hang out there. So it's a good place to know about if you have questions. Now, the code I'm about to show you is in this GitHub repository, the one at the bottom. So my account is under my last name, Kousen, and the name of the repository is JUnit5_workshop. I use that when I teach training classes and everything. I'm just going to show you a bunch of examples out of it. But that's where all the code is. You can go there anytime you like. If I make any changes, I'll just update it. You know, and keep doing that periodically to make sure I'm working with the latest version of everything. All right, so JUnit has one kind of confusing thing about it. There's really only one thing I still don't really understand even after using JUnit 5 pretty much since it was released. And that's the separation between what they call the platform and what they call JUnit Jupyter. The platform in principle is the foundation and Jupyter is the programming and extension model. But if you ask me what does that mean, I don't really know. What it really means is there's two sets of release notes I have to take a look at whenever they release a new version. But unless you're actually working on JUnit itself, you probably don't care about that either. The Java docs and everything else is fine. Now, Vintage, that's significant because Vintage is an engine that allows you to run JUnit 4 tests and JUnit 3 tests. And the real benefit to this is you don't have to upgrade all of your tests right away to start using JUnit 5. You can switch over to JUnit 5 with the dependencies in the build file and run all your old tests as long as you also add the so-called vintage engine. And you're good. And then you could just add new ones in JUnit 5, or you could port things test by test. IntelliJ has a little wizard built in that'll try to do it for you, and I've had mixed results with it. But the point is, there's no pressure. You can take your time, and as long as you add the vintage engine, you can, on a test case by test case basis, decide which one you want to use each way. Now, the nice thing about using the word Jupiter is it gives me an excuse to show one of those Juno satellite photos. You know, the satellite around Jupiter right now, I think it was a couple weeks ago, it hit what do they call perigove 60. That means it's closest approach to Jupiter again. Sooner or later, all the radiation out there will fry it, but in the meantime, we get cool pictures. The word Jupiter starts with the letters JU, just like JUnit. So that's bad. And to make it even worse, Jupiter is the 5th planet from the sun, so that's JUnit 5. So it makes me wonder what happens when they go to JUnit 6. Is that going to be Saturn or something? I have no idea. So at any rate, that's the only... Now, there is actually a reason to use a word rather than a number, and that is you can't trademark a number. So also, you can't have a package which is just a number. So the way you'll know you're using JUnit 5 is if you look at the import statements, all the packages have the word Jupiter in them. And then you know right away. Okay. Now, one thing I want to start off with is something that is different in JUnit 5 than in JUnit 4, but defaults the same way. And that is the lifecycle annotations. I mean, in JUnit 4, you're probably all familiar with at before and at after, and at before class and at after class. Well, in JUnit 5, they took the opportunity to simply rename those. The behavior is the same. I think before each and after each, that makes sense to me, test by test basis. And before all and after all, those also make sense. What changed is that the before all method must be static. If you put in a method that isn't static, it still compiles, but it won't behave properly. But the interesting thing to see about this is I have here in my repository a class called Lifecycle Tests. Now, how's the font size on that? Can you see that okay? For those of you who could see the recessed picture back here, you know. At any rate, notice at the top here, we have this test instance annotation. The test instance annotation says there's one of two options here. Test instance.lifecycle, which is either per method or per class. Now, per method is the same behavior as JUnit 4. And what I mean by that is the following. I put in a constructor just to say that's where we are. And then I have a before all method, again, printing out that we're there, and a before each, and then I have 1, 2, 3 tests, and an after each and an after all. So if I run this entire class, so I got to put my cursor outside any of the test methods, but still inside the class, and what you will see is that the before all runs before the constructor. And in fact, the default behavior here, just like in JUnit 4, is the class is reinstantiated between each test. So if you had any attributes, they automatically get reinitialized because the class gets reinstantiated. So you get this quadruple here: class before each, test after each. Constructor before each, test after each. Again, same thing. Constructor before each, test after each, and then after all. Now, before all, I can understand why that's static. I mean, there's no instance yet. But after all also has to be static, I assume just for symmetry. You know, just because they did that. But however, here's the new feature. I can change this from per class to per method to per class. And when I run it now, you'll see the behavior changes so that the test class is instantiated first and only once. So if we did have any attributes that needed to be reset between the tests, you'd have to do it manually. But this can be very nice. In Kotlin, for example, they often work with statics that way. Or in Spring, of course, Spring tests, Spring Boot tests especially, are JUnit 5 tests, and Spring test classes are singletons. So why reinstantiate the test class every time? You know what I mean? So people often will set the test instance lifecycle to be per class in Spring, just to save the trouble there. Incidentally, if you do change to per class, then before all and after all don't have to be static anymore. Okay? Although it doesn't hurt to have them that way. So that's the life cycle, and that's something that people always wanted to be able to modify in JUnit 4, and in JUnit 5 it's trivial, it's just an annotation. Okay, another kind of neat thing is that now you can set the test name to be something that isn't just massive words in camel case strung together. Camel case is fine until you get a whole bunch of words together and it becomes almost unreadable. That's what this one is, test with display name containing special characters. That's really hard to see. Now I took this right out of the user manual, and when I go over here and let me bring up the display name tests, I tried to identify where in the manual you could find this. But here, this is what I'd use it for, a custom test name containing spaces. See, that looks fine. This one is that guy flipping the table. This is the Monk scream emoji, you know, like that and everything. The point of that is it supports Unicode. So anything that's in Unicode you could do here. Whether it shows up on the test report or not correctly depends on whether you have the right fonts. That's all it is. Now I also put display name on the class, but I don't like using it there. If there's an error, I want to see what the test class is. But just to show what this looks like, if I run these here, then if you could see this, it says a special test case and then the 3 below it, and it uses the display name parameter right in there. So it's really helpful for like replacing camel case with spaces like that. Now they have another neat thing called a display name generator. And there's a handful of them that are built right into the library. So again, I took this from the user manual. This is an annotation called display name generation, and I picked the one called replace underscores. The other ones that are available are indicative sentences and simple and standard, and they all have their own definitions. But replace underscores lets you write a test like this if it is 0 with underscores, or down here if it is negative like this. And we're going to get to parameterized tests later because they're really cool. And when I run it, you will actually see that it replaces the underscores with spaces and makes it much more readable on the output test report. Now this is something I also want to mention that I didn't use for a long time, but I've started to find really nice use cases for it. You see the @nested annotation there? @nested goes on a class. Now it looks really weird to me the first time I did it, to put a class inside my class. And you can put a class inside the class inside the class. You could nest this again and again and again. What is it doing? All it's doing is grouping related tests together. It makes it so you could run just that nested set. So I have one here which has all those, the 2 tests, one of which is a parameterized test. And I separately have down here the indicative sentences generator. And you see on my output when I ran it, the group down here has the nested ones in it, the one that wasn't parameterized and the one that was. And that's what I find I use it for. When I put a whole bunch of tests in a test class, sometimes I like to group them together and say, yeah, these are all related, and these are all related, and these are all related. And that's what the @nested is for. It doesn't change the behavior at all. It's just grouping. And once I got over my distaste, I guess, of looking at nested classes in like that, it's a really easy way to group related tests. So I find I use that a lot more than I used to. So, okay. Assertions. Now, we've all used the same set of assertions that have been around pretty much since JUnit was first created. Assert true and false, assert equals with all the different overloads, assert null and not null, of course, assert same and not same as reference equality. Are 2 references assigned to the same object or not? That's assert same and not same. And fail, which was really funny back in the Wayne's World days, but that's been a while. You're all too young for that, I'm sure. Anyway, now those still work except for one interesting change. I don't think this is all that important, but it does matter when you're writing them. Remember how you used to put your own custom error message in these assertions? In JUnit 4, that message comes first. In JUnit 5, that message goes last. So they just moved it to the end. I'm not exactly sure why. But now they all are expected, comma, actual test, comma, optional error message. Okay? And those are fine, but here are the new ones, and one of them I really want to highlight. The assert all solves a problem we've always had in JUnit. And that problem is, if you did multiple assertions in one test class, the first one that failed abort the whole test. You don't run the others. And that's why people would say, oh, don't do multiple assertions in a test, split them among multiple tests. But I'm like, if I retrieve an object from a RESTful web service, you know, and it's got 5 properties to it, I don't want to retrieve it 5 times just so I could check one property each time. I want to test all 5. Assert all guarantees that all the included assertions are run even if one or more fail. And I'm going to show you that. I use that all the time, especially when I'm testing RESTful web services, when I'm getting back an object with lots of properties, and I want to check them all. Now, the other ones that are listed there I don't use as often, but they're still kind of neat. Assert throws and assert throws exactly. That's relatively new. Assert throws says the following executable, which I'll define in a minute, only passes if it throws this exception. But with assert throws, you can use a parent exception. You could say it works with just exception or even throwable, and it'll pass. Assert throws exactly, the .class references have to match. You have to get exactly the right one, which may or may not be valuable to you. Depends on your use case. So that is a way to get better control. Assert does not throw. Now that's kind of an interesting idea, because if you run an executable and it throws an exception, the test fails, of course. So why would you want an assert does not throw? Well, there's one use case for that. It's when the client might have expected an exception and you're saying, yeah, but it doesn't happen. I'll show you an example of that too. And then the last two are really slick, although I don't get to use them as often as I'd like. Assert timeout and assert timeout preemptively. The difference between the two is assert timeout takes a duration, and if you run and you exceed that duration, you're going to fail, but it doesn't stop it. It lets it run to the end and tells you not only that it failed, but by how much. How long did it go? So you'll know, oh yeah, you failed by 100 milliseconds or 200 milliseconds, something like that. If you're trying to check the performance and you need to satisfy some SLA, that's a nice one. Assert timeout preemptively runs the test in a separate thread, and if you exceed the duration, it kills the thread. So it doesn't care by how long you're going to wait. It says, yeah, you didn't make it. What I mostly use that for is I work with a lot of RESTful web services that are like a lot of public services on the internet. They're either up or they're down. If they're up, you'll get a result back quickly. If they're down, you'll never get a result back. So an assert timeout preemptively says, look, I'll give it 2 seconds. But if it hadn't responded then, it's not responding. You know, something like that, and I don't want it to have to wait for a network timeout. Okay, so now to show you how these work, here's my class called, naturally enough, Assertions tests. So at the top here, you can see the order of arguments. The expected value is 4, the test is 2 plus 2, and the optional error message now comes last. And you could do that as a method and everything, or as a supplier, and we're going to get to that. We're going to come back to that in a moment. Okay. In fact, you know what? I'm going to do that now. I have a different example, and this is really neat. I really think this is great. And by the way, I don't work for these people. Okay? I'm not a committer or anything like that. I'd love to be a contributor. I've just never gotten around to it. But I'm a fan. You know, I think, wow, this is really nice. So, but I can tell you what I really think. If there's parts of it I'm not wild about, I'll say so. What I have here is a lazy, if I can spell right. Yeah, here we go. Okay, now let me go to the JUnit Java docs. And it's taking its time. If it doesn't come up, I don't need it. Here we go. Okay. And all the assertions now have moved to the class called Assertions rather than assert. But what I want to show you in here is I'm going to go down to assert true. Okay, you see how there's 3 assert trues. One that takes a Boolean, one that takes a Boolean followed by a string, that's the optional error message, and one that takes a Boolean followed by a string supplier. The functional interface from the Java library, java.util.function.supplier. A supplier takes no arguments and returns an object, in this case, a string. And they call that the message supplier. You see the short message here doesn't say anything. Well, if I look at that one, well, first of all, let me look at the one that just takes the message. It says assert the supplied condition is true, fails with this message. But if I look at this one, Boolean and the supplier, it says, if necessary, the failure message will be retrieved lazily from the supplied message supplier. It's like, wait, what's going on here? Well, here, I have this simple method called create error message. I want to print out that I'm in it, and I'm just going to return a hard-coded string. I don't have anything fancy to do here. And in this test, I'm going to say assert true that true is true, which is true for most values of true, but sorry about that. And here's my call of the method. Now, I don't need the error message, right? True is very likely going to be true. So if I run this, though, you will see that even though I didn't need it, the message got created anyway, because when you put a method as an argument, it evaluates the method. And there it was. However, down here, the only difference is to the left, I have parentheses arrow. In other words, now I'm calling the one, wait a minute, let me make that bigger. Now I'm calling the one that takes the string supplier as an argument. And when I run this, now you'll see nothing happened. Now that wasn't magic. If you dig inside it, like right here, yeah. So let me go inside it. Then now I'm in the assertions class, and it's a layer of indirection, right? Every problem in computer science is solved by adding a layer of indirection, you know. So I'll go to this one now, and here's where the magic happens. If the condition is not true, go get the failure message. It'll call get on the supplier. But if it's true, just return. See? So they wrote the code to say, oh, if it's a supplier, when they go to evaluate it, they get an object reference, a reference to a supplier. And then whether to call get on it or not is based on that condition. Was the condition true or not? So they built in this mechanism. It's a really useful trick if you've never done it. If you ever have an object that is only created under certain circumstances, you can overload your API to say, well, we'll do one where you have the object and one where you have an object supplier, which you'll write code to say you only create it if we need it. Optional has a method like that. And another one that I didn't show here is that back here, I use something nobody ever uses, which is the Java util logger. This is java.util.logging.logger. I mean, everybody uses SLF for J or logback or whatever. This is the one built into Java. And again, the trick is they have it overloaded. So when I call an info message, it's going to create the message and log it. See, that's what this one's doing. I'm going to create the log message. So down here, I'm going to run it at, quote, fine level. I mean, isn't it ridiculous that it's not called, like, you know, debug or whatever we're used to? But, okay, it's called fine. And I'm not at fine level. So if I look at the eager one again, you'll see that, hey, we got this log message created, even though nobody's ever going to see it. See? But down here, they have it overloaded for a supplier of type string. And once again, the log message never gets created because you're never going to see it, because you're not at that level. And this one's even more obvious. If I dig into this one, no, I want the find here. So they actually say, yeah, okay, level of indirection, go to log, okay. And then here it is. If is not loggable at that level, return. They've got it built right in. So that's the lazy suppliers for the error messages. That one was for the logger, but it's also true for the JUnit optional error messages. Now, the other thing I was showing here is that the last argument in the assertions here was either a message or, again, a message supplier, and that's where there we got our laziness again. Is there a question? No, okay, just checking. Okay, and by the way, you could put it in as a lambda or as a method reference, doesn't make any difference. Okay, now this is the example I was telling you about to get to the assert all. I made a little method here called find by ISBN, takes an ISBN string, returns an instance of some record I called book. And I just have it hard-coded to say if it's this ISBN, then here's the book, you know? So this assert all says, okay, go get that book. And I want to check all 4 properties. If I look at the book, by the way, here's what the book looks like. ISBN, title, author, and local date. That's all it is. So here, I want to check all 4 properties. This is using an ISBN validator from the Apache Commons Validator project. So it has nothing to do with JUnit, but it works. And you can see I could do assert true here and assert equals for the title and the author, and that the book publication date is before now, you know, something like that. And they will all be executed even if one or more of them fail. And I use that all the time as a result. You can nest those, by the way. This says, okay, because this is an assert all, then this lambda will be executed, and this big block lambda will be executed, and this lambda will be executed. Oops, stop. IntelliJ trying to be too helpful. All 3 of those will run, and inside here, however, if the title is null, then just break out of that one. See, that's not in an assert all. The lambda around it is, but this one's not. If the title is not null, then we'll check that the length of the name is 3, then we'll do an assert all on all 3. See, it's a highly contrived example, but my point is you can nest these however you like to get the behavior you want, whether it's eager or lazy, whatever you want on that. Okay? So that's really helpful. Now, the exception handling is like this. It used to be in JUnit 4, you had @test with expected equals and you put the name of the exception class. The problem with that is anything in that test could throw that exception and the test would pass even if it wasn't the thing you wanted to test. Now, a legal argument exception, that's fairly common, but null pointer exception, that could happen anywhere. So what you do here instead is you use assert throws. Assert throws says, oh, we need this executable again, and then it has to be either exception or, if you're using assert throws, exactly the right class. Now this second argument here is what they call an executable. And an executable is basically a throwable that throws, it's a runnable that throws an exception. See, lambdas and exceptions never did play nicely together, right? You can't throw any exception that the single abstract method was not declared to throw. And runnable isn't declared to throw any exceptions in the run method. You have a run method, takes no arguments, returns void, doesn't declare any exceptions. So they made their own version of runnable called executable, which throws throwable, throws everything. And therefore, you can throw an exception, and it's not our problem. JUnit has to catch it. That's the nice thing. So it doesn't complicate our life either. So they made what is basically what I'd call a throwing runnable, if you will. Now, that comes up all over the place. That was the argument to the assert all also, was a vararg list of executables, or a collection or a stream, anything Java knows how to iterate over of that. So here's the assert throws and the assert throws exactly. Now, the one I was telling you about, where do I get the assert does not throw? Well, like so many people in IT, I was a career changer. I switched from basically an engineering field. And a lot of my code was, well, my life was a lot of math and a lot of Fortran. The nightmares went away, but it took a while, you know. And the thing that happened in Fortran is you're doing all these numerical calculations, and if you ever did a divide by 0, then you wanted to know about it because something went seriously wrong. Well, according to the IEEE 754 specification, for all programming languages, if you do a divide by 0 with integers, that does in fact throw an exception. Java will throw an arithmetic exception, divide by 0. But if you do a divide by 0 with floating point values, with doubles, you don't get an exception. You get infinity. Seriously, you actually get double dot positive infinity, believe it or not, or negative infinity, depending on what the numerator was. And this is not something most people expect, but that's according to the specification. So here I have an assert throws that does in fact throw the arithmetic exception when I divide 1 by 0. But this one I'm using an assert does not throw, because those are doubles and you might have expected an exception, but you don't get one. So really all that is documentation, but it can be useful. I don't have too many other examples where I need something like that, but you see where that could be useful. Okay, now the timeouts. This one says assert timeout, and the first argument's a duration. So I'm going to wait 100 milliseconds to print hello. Again, that's an executable. Okay? Printing hello should not take 100 milliseconds. I mean, if it does, I have some serious performance issues. No, we're good there. But now here is assert timeout with a thread.sleep of 200 milliseconds, or an assert timeout preemptively with a same thread sleep. Now I disabled them both. Let me re-enable them temporarily. And with the one that says timeout exceeded, you see it says execution exceeded timeout of 100 by 105 milliseconds. I mean, it didn't quite cut it off in time, but it told me roughly how long it missed by. Whereas if I do the assert timeout preemptively, it just stops it and says, yeah, you exceeded the timeout period. Again, I'm a little disappointed that I have not had a lot of reasons to use this, but that's something I could not have done in JUnit 4. I would have had to write my own threading, you know, to spawn the thread and monitor it and check all that stuff. And here it's built right in. Neat little feature. Okay. Now, yeah, I mentioned these executable interfaces, and which is basically a throwing runnable. There's also inside JUnit a throwing consumer, which takes an argument and returns void, but throws throwable. And there's a throwing supplier, which takes no argument, returns an object, but throws throwable. They don't come up as often, but they're there. I actually have a little video on that on my Tales from the Jar Side YouTube channel if you're interested. Okay, now, assumptions, I'm just going to mention because we're not going to have time to get into it. This is something Java's never really had. We use exceptions in Java for what we really call precondition checks. A precondition needs to be true in order for the postconditions to be valid. Like I ask you to write code for me and you say, well, you got a project number? You have a budget? I mean, that's a precondition. I can't just ask you to do something without being able to fund it. You know, I may or may not have control over the preconditions. You know, who knows? But those have to be satisfied if the end result is, yeah, here's your code. Something like that. Well, we use exceptions for that. I mean, what's a null pointer exception other than a precondition failure? I mean, you didn't actually get to run the thing you were trying to test because the pointer was null or the reference was null. So no good, right? Well, in JUnit 5, they have an assumptions class that has an assume true method that's purely for precondition checks. If you put in the precondition check and the test fails, or the precondition fails, the test is aborted. It's like skipped. It's not failed. You get like a circle with a line through it in the output report saying, yeah, we never ran, you know, because you didn't pass the preconditions. Now, whether you choose to use this or not is up to you. If you find it helpful, great. You know, but now it's built into JUnit. It'll be interesting to see if people adopt it. Okay? I do have an example in the repository. I just don't want to take the time to bring it up now. I want to get to conditionals and parameterized tests. And if we have time, I've got a couple other ideas, but those I definitely want to show you. Now, conditional execution. This is beautiful because it is not only powerful, it's simple. And that's a nice combination. JUnit will allow you to say on a test-by-test or class-by-class basis, only run this on the following operating systems. Run this on Windows or on Linux, but not on a Mac. Or you could do it on JRE. Run this on Java 11 and Java 8, but not on 17. Or you could even do a JRE range. Run this from 8 through 17, but we're not looking at 21 yet, something like that. You can do all that. I'll show you that in a minute. You can also do it based on an environment variable or a system property. It'll actually use a regular expression and try to match the system property. Now, those properties, you often use things that look like Booleans for that, but it's all just strings. These are regular expression matches. You can even do this for some generic method that you write that returns a Boolean. Let's see how it works. So first of all, there's enabled on OS or disabled on OS for the operating system, and there's OS as an enum. And like this is an abbreviated list. I think there's more now. Good old AIX, you know, Mac, Windows, Linux. Good old Solaris. You have any of those left? And my favorite, you know, other. Right. I think they've got a BSD in there now. You know, they got a bunch of them. On the JREs, they have JRE 8, Java 8, and nothing lower than that because JUnit 5 requires Java 8 or above. So you can't even try on Java below that. I believe they have 22 now, and they'll try to keep up with whatever's available in Java. And then other, which I have no idea what other would even be in that case. Now, let me bring up my example here. So this is conditional tests. So here, this test is enabled on a Mac only. It only runs on a Mac. This one runs on Linux, Solaris, or Windows, but not on any other. See, you put them in braces like that, just like an array, separated by commas. This one runs on Java 8 only. This runs on 8, 11, and 17, again, with the braces, using the JRE enum. And have they added more? Yeah, see, they're up to from 8 through 22, and other again, yeah. This one runs on the range from 8 through 17. Now the min defaults to 8, and the max is supposed to default to the current limit, but I don't trust them. I'd always specify them anyway. I mean, maybe you'll work it out, but if something goes wrong later, you're gonna have to work it out again, and you might as well say it. It's not that much. This one I did play around with a min and a max by themselves. Now this is a system property. Remember, you can set a system property on the command line with -D. So I said CI server is the property, and it matches the string TRUE. Okay, it's not actually a Boolean there. Again, I got that from the docs. This one looks for the architecture os.arch system property, and the regex says, is it a 64-bit operating system or not? That's what that's doing. And then here is the same thing for environment variables. Like if I run this, I'm on a staging server, I'll run it, otherwise don't. And then here is a method that says, actually this test looks for a method called custom condition, which is down here. You can write any code you want in there, but the method can't take any arguments and has to return a Boolean. And this will look and say it's enabled if that method returns a Boolean, or this is disabled if that method returns true, whatever. So that means you could write any code you want inside there. Easy and powerful and really obvious what's going on in all of them. So I find that really, really helpful. Okay, so that's the conditional stuff. And then, yeah, here they are listed as inside here. And we did the life cycle, already did that. And now, ordered tests. This has one of my favorite phrases in any Java doc, or any, not Java doc, but the actual reference docs anywhere. If you look and see what order do JUnit tests run in, and I don't mean the classes. I mean, if you have a single test with, say, 10 tests in it, what order do those tests run in? If I asked you, you know, you'd probably say, I don't know, top down, or you might say alphabetical, or, I mean, it could be anything, right? Well, what they say in the docs is the order is deterministic, but intentionally non-obvious. I love that. Deterministic, meaning it'll be the same every time. It's not random. It's deterministic, but we're not going to tell you what it is. Intentionally non-obvious because they don't want you to rely on it. They want your tests to all be independent. But there are times when you do want an order. when you actually care. Do this first, and if this works, then do that. And for that, you add in an orderer, believe it or not. And there's a handful of orderers. You could put in an orderer that will go by display name, which defaults to the test method name if you don't have a display name annotation. Or you can go by the method name explicitly. Or you could go in random. It'll be pseudo-random each time. Or you could use the order annotation, which is the one I have here. So this one says, I put up here, test method order uses the order annotation. Again, I didn't write this. This comes from the docs. And then here's order 1, order 3, order 2. They'll run the null values, then the empty values, then the valid values, one by one by one. And now you have control over it. But if you don't put it in, it's deterministic, but intentionally non-obvious. I got to find places to use that phrase. That's nuts, you know? Anyway, so there's that, in case you're wondering. Again, in JUnit 4, you didn't have any control over it. Now the best part. This is the one that really closed the gap with certain other testing tools. I was a Groovy programmer for a number of years. I really liked it. Spock tests are still wonderful. I really like the Spock framework. This is something that Spock always had that JUnit didn't have until comparatively recently. With parameterized tests, you could run the same test with different data. See, they also have something called repeated tests, which I'm not even bothering to show. With repeated tests, you run the same test with the same data. So unless you've got something random in there, you're looking for something flaky or inconsistent, or you're doing something random inside the test, that's the same. I don't get a lot of value out of that. But parameterized tests say, oh, here's the source of data, run it for each of these, and give me a different test output for all of them. So it looks like you're running a dozen tests, and you are, you know? What you need for a parameterized test is a source for the test data. Value source is pretty common. It's generally a collection of primitives or strings or classes. Enum source will run through every property in an enum, although you can actually limit it to certain ones that satisfy a regular expression, something like that. Method source is my favorite. Method source says, call this static method. You give it the name of a method. It takes no arguments. It returns something Java knows how to iterate over. A list, an iterable, really, a stream, a collection, well, I said a collection, an array, or an iterator. And it will iterate over it for you. See, now this is where I always make a joke that works in the US. I'm not sure how it will work here. I'd say a CSV source goes to the drugstore and pulls various values out of that, because that's a CVS source, right? I mean, but again, I don't know how well that joke works in India. No, they're looking at comma-separated values. And the difference between the CVS, now I'm doing it. The CSV source and the CSV file source, of course, is in the CSV file source, you put your data in a separate file somewhere in the class path, tell it where to find it. You can even skip header lines. And then the argument source I'll get to, that allows you to get multiple arguments. So here's my example of that. Parameterized test. Okay, so here is a parameterized test looking for values that are prime and less than 20. And I have a value source that takes ints. So that's a collection, an array of int values, lowercase ints. And as you might imagine, if I look at what are the possible arguments here, there's shorts, bytes, ints, longs, floats, doubles, chars, booleans. Those are all the 8 primitive types. Strings and classes. Strings I've never had a use case for classes. I'm not sure what I would use that for. But whatever. The only problem is here you see you have to hard code in the data. So you really do have a specific set you want. But notice how now your test case has an argument. We're not used to test cases having arguments. That value is plugged in, and you'll see here that I get a separate output for each of the individual test cases, each parameter. Just really nice. Shows up beautifully in JUnit or in the IntelliJ. It shows up just as nicely in Eclipse-based frameworks as well. It's on the Gradle test report. You see them all separately, but they don't group them necessarily. So that's for primes that are prime. Here's ones that are composites. But here is a method source. The method source says, let's call this method called primes less than 100, which is right here. Again, this has to be a factory method, no arguments, a static method, and it returns something that Java knows how to iterate over. And whatever you get back, it will run them all. So you can see I've got all those outputs on there that all came back as the method source. And that's really convenient. I use that all the time. Now, this one brings up the argument source idea. The problem with those other sources is that they all return a single object, one int or one value, whatever. With an argument source, use arguments dot of, and you could group arguments together. So this parameterized test is using a method source called max with args list, which is right here. This says make an array of, or array list actually of, arguments dot 1, 2, and 2, 7, 3, 7, 2, 4, 6, 8, 5, 5, 5. What is this doing? It's going to take those values and it's going to match them up to the arguments here. I have int x, int y, and int max, and I want to say the max of the first argument and the second argument is the third argument. You can imagine you could adapt that to like database data or something like that. And in the method, you'd return it. So this one, it's even going to do the type conversion from the string with no problem. This one, it's going to ignore the last argument because I gave it one too many. This one, I had to comment out because I didn't give it enough arguments. And this one, they will all work properly. So if I go to this test and run it, you'll see max of 1 and 2 is 2, 7 and 3 is 7, just like you would expect. That's what an argument source is for. It's for grouping your collection of arguments together. Very useful. And then here was the enum source. Here's the one from the docs. It said, let's do an enum source on good old chrono unit in the java.time package, but we don't want all of them. We only want the ones that match this regular expression, which means that the name of the chrono unit ends in the word days. And it'll just check it. And again, if I run it, you see I get half days and days, something like that. This is the CSV source. First argument, second argument. In my case, it's two strings, a title and a URL. So I check the title's not null, and I have a URL validator also from the Apache Commons validator project. You can specify the delimiter if you don't want it to be a comma. It's ignoring the extra white space after the comma. But this is the one I use the most down here. CSV file source. And this bookdata.csv under resources is in my source main resources folder right under here. And you see I have ISBN, title, author, publication date. I got some syntax highlighting in there, but that's not me. That's just straight text. You know, but they've got the little plugin in IntelliJ to format it for me, which is nice. And back here you see that this also says num lines to skip. We could skip the first line, which is my header line, and then use the rest. And it's even converting the string, the ISO 8601 string, into a local date for me. So it's 4-digit year, dash 2-digit month, dash 2-digit day, and it parsed it out without a problem. And then I could check all four of them. All I'm doing here again is checking the ISBN to see if it's valid, and checking the title and author, not null, and that the date is after 2013 and is before now. That's another message for you. I didn't write my first book until I was 50. It's never too late, okay? So, at any rate, this works for all of them. And again, it gives me an output that's separate for each of them in there. And I only wrote out checking the title just to show how that works. I think on this repository I added an MIT license, which means you can use it for whatever you want, pretty much. I mean, even commercial stuff, you could wrap it in there. I mean, it's just examples. And as I say, probably half that repo is examples directly from the user manual that I wanted to run. You know, I'm like, well, it's nice to see it, but I want to see it in action. So I started off this repo by adding those manually, and then I kept adding more as time went on, things I use in classes and stuff like that. Now, the only awkward part here, oh, it looks like I already did it. I'm sorry, I skipped a step, I think. Instead of just putting in, oh yeah, here's where I was. See how it's string date, ISBN, string title, string author, date, local date. We don't usually separate our values like that. Instead, remember, I already have a record called book. I'd rather write my test in terms of book because then the ordering and the attributes doesn't matter anymore. If I have it in terms of book, which I think I have up here, yeah, see the argument this time is book, and then everything is book.isbn, .title, .author, .publication date. Now I've added a layer of indirection, right? But I've made it a bit more robust, doesn't matter what the order is. Well, how do you get it to do that? Well, what I needed is this thing called aggregate with. The aggregate with annotation says, write your own, quote, aggregator. And let me show you my aggregator here. The aggregator implements this interface called arguments aggregator, and what you have to do in your method is put in the arguments, access them, and return the object you want. So this takes the string, and date, local date, and creates a book. And when I use the argument aggregator over here with the aggregate with, now my test is written in terms of a book. Again, you may or may not need this, but it was easier to do than I thought it was going to be. And then I even took the extra step, which I never would do this, but I did it anyway. I actually wrote my own annotation, which is called CSV to book, comma separated value to book. And all it is saying aggregate with the book aggregator, and that's it. That's all I had to do. And now it's easy for a user to read it. Oh, taking CSV, turning into a book. And again, there it is right here as the argument to my book source using the book data, and it works like a charm. So that's most of the nice features, but there's one more, and I think we got time to do that. So in the slides, I do have the information about those, but here, this is still considered experimental. I didn't show anything else that's still considered experimental. This one you probably want to know about. If you're a Gradle user, then merely by setting the max parallel forks property inside the test block to some number other than 1, you could run tests in parallel, but not really. What you're doing then in Gradle is you're running the test cases in parallel, but not the tests in each test case. So if I have 4 tests in one test case, they're going to run in their deterministic but non-obvious order, no matter what. Here, if I go into JUnit platform.properties, add it to my class path, I can set parallel enabled and parallel mode default to concurrent, and now all the tests will run in parallel. And since your tests are supposed to be independent anyway, that can speed things up. So if I go back to my assertions demo, so this is the one that has a bunch of tests in it. So let me run them all. And you can see that doesn't take long to run anyway. But there they are. But what I have in my source main resources folder is this JUnit-platform.properties. And all I do is re-enable parallel and execution parallel mode default to concurrent. And now when I run, bang. I mean, they all ran in parallel. I'm not showing it. I have better examples of that. In fact, I have an example where I was testing out an online REST client. And that one was like, had a get by ID method. And I knew they had 100 options. So I could run it not in parallel, and it shows me 1 through 100. But if I run them in parallel, then they're all in different order and just zips right through it based on how many. I think it uses a fork join pool using the number of processes on your machine. The same way the parallel streams work. I think that's what they're doing. This, however, is still considered experimental. So it's subject to change, although it hasn't changed in a long time. So I think it's worth trying out. You might want to be sure, because again, you don't want to do anything stateful in parallel. You don't want to do tests in parallel that actually require a certain order. But in general, this is going to speed things up enormously. Now, there are extensions. I've used the Makito extension. They don't have what they used to call a run with, on JUnit 4. That's been replaced with extend with, and there's a collection of extensions. You could find a list of extensions on the wiki page in the JUnit GitHub repository. I don't know how often they update that page, so it may be out of date. But Spring, for example, the Spring Boot extension, well, here, in fact, I have a sub-project in my repo called Spring, and this is a Spring Boot project with a a Spring Boot starter and Spring Boot starter test and assert J and an H2 database. And if I look in the test class here, see how it's got Spring Boot test on it? If you look inside Spring Boot test, there's extend with the Spring extension class built right in. So you don't have to do anything to make that work. I'd say, yeah, run it on from Java 8 to 11, and I can take advantage of any of the features of JUnit I want in my Spring test. That's built right in. I've used that extension a lot. In fact, it's hard not to use that extension when you do Spring Boot. I've used the Mockito extension. I know there are several others. I haven't done them, and I certainly haven't taken the time to write my own. But they all seem to work. The other project I have in this report, or in this repository, is a vintage project as well, which has some JUnit 4 tests. And again, the Gradle build here uses the JUnit vintage engine. And if I look in my Gradle repository, here's my JUnit vintage engine as well. You know, the regular one and the vintage engine. At any rate, it's all self-contained. It's all runs in there just fine. Okay? And I believe that's pretty much everything I wanted to tell you about. JUnit 5, I'm really impressed with the changes they've made, especially because of the backward compatibility and the fact you can gradually upgrade. There are plugins for IntelliJ that will help you upgrade if you want, and also just help you run them, you know. I use Mockito. I wrote a book about it, you know, I mean, for what it's worth, and I have a talk about that. I think it's on Friday. Assert J is the most awesome syntactic sugar library I've ever seen. You know, it doesn't change anything, but it's a nice, easy way to write things. And it's kind of replacing the Hamcrest matchers over time. And then again, I've got this Tales from the Jar Side newsletter and YouTube channel. I've got a playlist on JUnit testing and everything. I'll give the slides to the people here. That's everything I have. So thank you very much for coming.